So I guess let's do some quick introductions here. So I'm Erik St. Martin. I work on the developer advocacy team at Microsoft with Paul here. Do you want to give a quick introduction to yourself, Paul, and kind of what you work on?
Sure. So today we're joined with a bunch of our friends from NVIDIA as kind of an end cap for all of this July OT streaming that you and I have been doing over the last month, if you will, which is consisted of us building primarily this intelligent video end-to-end application. And the cool thing about that is we're now joined here by the experts that have really built the hardware that was pivotal in being able to create that. So in my role at Microsoft, just to switch over to an introduction here, I function as a cloud advocate focused on Internet of Things technologies. And this has primarily been a focus with computer vision workloads and GPU accelerated workloads at the edge, typically in containerized format. And I've had a lot of fun messing with that for the last year, as you can see, and we've had fun messing with that for the last month. So now we're joined with our friends who will allow us to go a little bit deeper to talk about all of those technologies that were employed in that solution.
And I guess let's do a quick round of introductions for our folks from NVIDIA.
Hey guys, this is Chintan here. Thank you, Erik and Paul, for hosting us. We're happy to chat with you on IoT and how NVIDIA GPU can help accelerate AI workloads. I'm Chintan Shah. I'm the product manager at NVIDIA, and I manage a few of our AI toolkits. One is DeepStream, which I think we'll talk about a little bit about today. It's a streaming analytic toolkit for video analytic applications where you want to use AI to do some perceptions or on the edge. And then once you get that data, you want to connect to a cloud provider to like Microsoft Azure to send your data to the cloud. With that, I'll pass it back to you, Erik. Thank you.
Okay, so
yeah, hey, I'll go next.
Oh.
Ryan Huff.
Go ahead, Ryan.
There's our delay. Yeah, Ryan, based out of the Seattle area, work with Microsoft, focused on edge solutions. So I'm working with Paul and team, and then all the other edge solutions that NVIDIA and Microsoft are partnered on.
I'll go next. This is Jaime. I also work in the Redmond area. Basically, we support Microsoft on a lot of the edge use cases. So Paul is one of our kind of customers or people we interact with regularly. And so, yeah, I would just want to thank you guys, Paul and Erik, for making all these videos. They're just amazing. And we're going to use those as well to learn not only about the interaction between NVIDIA and the cloud. So it's just very useful to have the code and the videos together. It was very useful for me to watch those. Tenika,
awesome. And yeah, I'll pass it over to Tenika.
Awesome. Hi, guys. Great to be here today. I work at NVIDIA on the embedded business. I support marketing for the Jetson, Isaac, and robotics platforms. And I work with Paul regularly. He's a great partner to NVIDIA, and we, work together on, just evangelizing about all the cool projects you can do with Jetson and specifically NX and Nano recently. So great to be here, and yeah, thanks.
And so I guess what I'll do first is kind of give everyone a glimpse into what we're referring to when we talk about the video series and things like that, how we kind of got here. So Paul has been working on this system, and he would graciously spent a month of live streams with me teaching me this stuff. I'm going to quickly switch over to my desktop here. I sent out the GitHub link in the Twitch chat, but this is what we're referring to. This is the entire project we worked on, and kind of each of these modules are the live streams that we did are included here. And we kind of built this end-to-end intelligent video analytics system that, and I can show you because I have it running here. I took a couple of cameras and hooked them up in the house, and we did some custom vision to do object detection and collect analytics on these things and map them all out, send them to time series insights, and then ultimately a Power BI dashboard where we could track, the detection of things in different places of the house. And so this was all done on a NVIDIA Jetson Nano device that's sitting over here next to me. And so that's how we got here. Now we get to talk with NVIDIA about what else is possible. Where can we go from here? What other types of things can we do on these devices? Hopefully fill some knowledge gaps that I know I definitely have on GPU accelerated workloads and things like that.
So I've kind of been teasing a lot online about what one of the questions is that we'll be answering. And this topic came up really early on, actually, when Erik and I were beginning the live stream series, where there's actually a number of different ways out there if you want to do advanced types of AI inferencing workloads on devices. There's a number of different hardware offerings for that. So these include things like VPUs, or virtual processing units, they call them, FPGAs, or field programmable gate arrays, ASICs, which are integrated circuits, and of course, the thing that NVIDIA is just known for, which is GPUs. Now, this is a tough question, and I realize we could go down a rabbit hole on this for an hour, but let's try to keep it boxed within like a 5-minute answer. But real talk, GPUs, how do they work? Like, what is it that makes them so much better than a CPU at performing inference types of workloads across devices?
Chintan, you want to kick it off, and then I have a couple ideas here.
Yeah, definitely. So very good question on the GPU, why GPU is better. So one of the advantage that GPU has, let's say for inference type of workload as compared to a CPU, is a GPU is nothing but a lot of smaller cores running in parallel. And when you're processing AI, computer vision type of work, you have pixels coming in, and you want to process those. You have multiple streams coming in, and you want to process those in parallel. And you want to use the capability of GPU to do like SIMD type of instructions. You have single instruction, multiple data, where it can parallelize over n number of cores, and that's where GPU kind of accelerates over CPU. CPU is great for a lot of complex tasks, but it's very sequential for a lot of tasks which require decision making. CPU is great for that, but for tasks which are kind of, okay, this is the instruction, this is the data. Now let's go and run some complex matrix multiplication. GPUs are great. And where GPU accelerates over like ASICs is the flexibility of GPU. So you can program GPU to handle any type of networks. So with ASICs, you're kind of boxed into maybe 1, 2, and 10 different types of networks. But if your need changes in the future, networks become more complicated, as we've seen from just a couple of years ago. GPU can handle that better. It can scale better. So that's why a GPU is much better for inferencing type of task, for any AI type of task. So yeah, I'll pass that to you.
So you hinted there at matrix multiplication, and I just want to, before we go too deep in the tech piece, that's important for object detection algorithms, because from what I understand, of course, I like skipped all of that. I've got the book, but of course, I didn't read it. It's all matrix multiplication at the end of the day, and that's what these things do so well. So I just find that very fascinating. The one interesting thing too I wanted to talk about is NVIDIA, like where y'all sort of started as a company and where you all are at today. So when I think back to the mid-90s, NVIDIA was the thing you put in your computer to be able to run Crysis or whatever the game was at the time. It was a big, like, you could say it was for gaming, but really, I mean, it was for high performance graphics. And obviously, the company does a lot more than that. So can you walk me through maybe a little bit of the history, where NVIDIA has started, and where y'all are sort of going today in terms of what is the levels of innovation and where you're seeing the most impact with your hardware?
Yeah, so going back to the beginning, NVIDIA was founded in '93, and you know that was true. You know, you had NVIDIA creating GPU boards, but then at one point there was 70 manufacturers creating boards. So as the time went on, you know, pared down, and I believe you know, I was a big fan of 3DFX. That was NVIDIA picked up all those assets after they folded in, and then after all the dust settled, NVIDIA was the last one standing. That was still a wholly independent company, right? And so if you go look at you know, success with Xbox One, the original, not the current Xbox One, you know, landing the GPU in there, landing the PS3, great success with the video card industry. And then somewhere, you know, 2015 time range, you know, forget the cryptocurrency boom, right? So that was great. And so obviously the company knew they had to diverse from that, right? And so they started focusing on accelerated computing. So 2015, machine learning adoption, HPC workloads coming on board. And then starting in 2016, we really started to see the AI boom. And from there, it has just accelerated. And you can see the performance bumps as the new cards are released, you know, 2x, 20x, you know, the latest GPU is a 20x improvement over the last GPU, going from a V100 to an A100, right? And so Moore's law is blown out of the water with GPUs. If we look at what we're doing with the NX versus the Nano, in a little, how many watts is the NX package? Maybe 30 at peak, or is it even that high? Or the amount of power? Right, so it's even lower. But watching the video stream with you guys, yes, the Jetson Nano can be a little underpowered, but that's why you can scale it to different hardware. So at a 5-watt package, you can put that in a video camera. You can put that in any device with 5 watts and have activity or inference on that device, right? So that's all on the edge, and you know, that's what I think we may focus on. But I can go on longer what we're doing in the data center, medical, imaging, you know, what we're doing in COVID, autonomous driving. NVIDIA's in all these markets.
Yeah, and just to add to
actually, I would like to hear a little bit more about that. So sorry, the COVID I heard. So we've asked here about like how the hardware works, and we've got a little bit of the history of the company. So yeah, how are you all tackling the biggest issue of today with GPUs? How does that come into play?
Well, NVIDIA, you know, we're powering some of the top supercomputers in the world. So maybe 80% of the top supercomputers are powered by NVIDIA. So all of those are working at full scale for COVID processing. So, you know, testing drugs, proteins, rotating the proteins, see how they attach or block the COVID from attaching to the human proteins, all the way to doing inference on the edge on a medical device. So say there's an X-ray or a scan, they're actually detecting COVID at that point based on the patterns within the imaging. And then actually someone did ask on one of your streams about social distancing. So if you go Google computer vision, social distancing, there are tons of companies already building these networks for you to use or purchase. I think, you know, that's their value add, is that IP for that network, right? So here we're on this channel, where do you go to build these yourself? But if you do a quick scan, face detection for a mask, social distancing, get alerts, you know, people counting, temperature detection. So really it's up to the creativity of the community, right? So we're providing the frameworks, the APIs, and it's the community imagination is where we're at.
Yeah, and it was interesting from our perspective seeing you guys, Erik and Paul, working on this project, right? Because like Ryan said, it's just a this is a device that you can just use for it's a multi-use device. You can use it for whatever your imagination can create, right? So making you guys used it for cameras and security detection, but I mean theoretically you can attack all the different problems. In any problem that you can see is like, oh, what if we use this model, or what if we use GPUs for accelerating this particular problem? So so it's just all up to our creativity to see what we can make up.
Yeah, for us it was a Raspberry Pi on steroids.
That's a good way of describing it.
So Erik, you're headed toward the NX, or are you going to get the larger form factor, go all in, so you can start processing 70 cameras?
Yeah, so the one thing
What's next for you?
we did discover was the Nano was really, really awesome for doing this type of stuff. But we found that we couldn't keep real-time video while doing object detection. So we had to kind of do object detection, like, what was it, every third frame? Is that what we ended up with, Paul? And then in addition to that, like, I want to do multiple cameras. And I want to do the full YOLO model. So I think I have to go to the NX. So
Ryan, you hit at something there, and I love that like, I guess synonymous of comparing this to the Raspberry Pi, and it just makes me think about community, and that was brought up. I think Tenika, you might be able to share some insights here. Is there a community for the developers of this Raspberry Pi on steroids, and where do folks get started for that? So folks that have no previous uses with this hardware.
It's a great question. We do have a Jetson, excuse me, losing my voice. We have a Jetson projects page, and it's a great place to go and get inspiration online about Jetson projects that are being built on NX and on Nano. And it actually has a really cool video that gives you an idea of the types of projects people are building, everything from drones to yoga projects where it helps you figure out if you're doing your yoga pose correctly. And that's one that I really love by Peter Hahn and Sarah. It's called Mixed Pose, actually. So if you go to our Jetson Community projects page, that's a great place to get some project inspo for Nano. Another place to go is the NVIDIA's Learn AI page. That page will walk you through how to get a Jetson, how to explore projects built on Jetson, and also just how to get started, how to unpack your Jetson Nano.
yeah, so
excellent. Actually, while you were naming those off, I was copying the links to those into the chat here. And actually, maybe we could talk a little bit more about that the project from Peter Ma. I've actually met him in Beijing, of all places, is where we met. That's a cool project. If you want to talk a little bit more about what they did there, it was like a Hackster winning project, if I recall.
Yeah, Mixed Pose. So he's actually such a cool guy. I mean, they just won a big Google competition, or were featured in a Google competition. So if you haven't checked out Mixed Pose, you can go to hackster.io/mixedpose. And you can get more information on it. But basically, it was AI on the edge, streaming a platform for yoga instructors and fitness coaches. So the platform allowed you to understand if you were doing your pose correctly and what adjustments you needed to make. They have some really good information on the Hackster.io and on their GitHub. So I will add those links just so people can dig into the code and the background a little bit more.
Awesome. Yeah, we're sending links over. I know some of those might not have shown because we needed moderator access. Those are coming through. Apologies, folks in the chat there.
Yeah, and so we ended up using the DeepStream SDK. I want to talk a little bit more about that and sort of how seamless and straightforward it makes doing some of these pipelines. But I'd also like to move into some of the other areas we didn't explore, because I know that you also have libraries for doing things like robotics and autonomous vehicles and things like that too. let me paste these links over that Paul's sending real quick. And just to let everybody know, we will field questions throughout this entire stream. So if you've got questions about any of this stuff, stream analytics, the intelligent edge, the NVIDIA devices, deep stream, all of that stuff, ask questions in chat. I think almost all of us are paying attention to chat. We are happy to field all of your questions. We will keep asking questions ourselves in the absence of your questions, but we definitely want to make sure anybody who is watching that your questions are answered.
So I just want to say, in addition to, since you were talking about other libraries and other platforms that we have, I don't know if you guys, for all the data scientists and chat room or data engineers, I'm not sure if you guys are aware of the library that we have. It's called Rapids. So a lot of, if you guys come from like data science point of view, you're probably using like pandas and a lot of the Python libraries. And so Rapids is basically a GPU accelerated library, but it's very, if you ever use pandas, you can just quickly switch to Rapids, and it's almost like seamless. And we have been working a lot on getting that library, so that it plays very well with GPUs, and so that when you have a pandas script, you can easily change from pandas to Rapids and without much of a hiccups and stuff. So check out Rapids. We've been doing a lot of improvements on algorithms as well. XGBoost is a very parallelizable algorithm that a lot of data scientists use. And so if you're into that, if you're coming from that background, that's one of the areas that we are working on as well. So just an example of another library or another framework that we use as well.
Yeah, I think that's a good point. So Rapids is for the analytics side of it. So that's where once you have collected all this data on an intelligent edge, you send it over to the analytics side of it to do some further analytics, to learn different patterns. There's also the edge side of it, the intelligent edge, what we call the perception side of it. So this is where you take the sensor data coming in, and this could be video streams, this could be audio, this could be IR camera, thermal camera, any type of camera. So you have all those different streams coming in on the edge, and you need a efficient SDK to process those. So one of the one that Erik talked about is Deep Stream. So Deep Stream is a streaming analytic toolkit to take in streaming video data, and video represents probably that has the most amount of data in a pixel. In a like 1080p pixel, you have more than million pixels, RGB pixels. So you have lots and lots of data coming in. And to process all of those data in parallel requires a lot of computing power. So what we have created with DeepStream is we've created this efficient end-to-end pipeline. So you have streaming data coming in, and you want to use AI or deep learning to convert those pixels to some insights. And that's where DeepStream can provide all the other pieces. So when you have video data coming in, you have to do some decoding, pre-processing. Then you might, and this might involve scaling down an image. This could be dewarping an image. Then before you send it for inference, you might need to batch these together so you can optimize your inference. And then you do your inferencing part. And once you have done your inference, you get the insights that you need. The next step is you could potentially want to send this over to the cloud for further analytics. So all of this can be done in a seamless toolkit called DeepStream, and it's available for free to download on our developer page. And it's also available on Azure Marketplace. So it seamlessly connects with the Azure IoT. So you can run DeepStream on the edge on a Jetson Nano, and send the metadata information to Azure IoT, where you can build dashboards and do further analytics.
So you said a lot there, Chin, on what DeepStream does, which if you boil down the problem it solves, I think you start to realize why there's so much involved there, which is deep stream. My understanding, and y'all correct me because you're the experts here, it is an SDK that is designed to streamline and optimize the development of what we call intelligent video applications. So I guess that's like an app that would take in, in number of video sources, produce inference results, and then maybe deliver those results to a third-party service. But if you think about that, there's so many edge cases that are involved there. Like, how do you optimize, if you have 60 cameras, let's say, how do you optimize the grabbing of the frames and ensure that maybe you're doing the decoding of those frames on the GPU? And how do you, then when you run inference, is there maybe like a step where you stitch the images together so you only run inference once? And if you think about trying to shave that yak by yourself, you're going to be busy for a very long time as a developer. And so what I found really interesting is that it solves all of those problems you just described, but it does it so elegantly in a way that's accessible. And what I mean by that is by simply updating the deep stream configuration files that essentially become your application. If you can wield a text editor, you can all of a sudden not only develop intelligent video applications, they're optimized and accelerated too for you. If you want to maybe go into that detail, like it does that, right? I mean, it grabs the frame in an accelerated way.
Correct. So there's a couple of things that we do in DeepStream, and again, we use our SDK consists of all the different software SDKs from all our NVIDIA, and what we do is we actually put it together in an efficient pipeline. So basically, we try to maintain zero memory copies between things like decode, pre-processing, inference, and so forth and so on, which is where you actually get the latency or performance boost. So decoding itself is a pretty compute-intensive task, and if on our GPU, on our Jetson, as well as on our larger GPUs like the T4s, V100, A100, we have a special decoding hardware accelerator on our GPU itself, and we utilize those for decoding tasks, and we are able to parallelize those particular decoding. And once the frames are decoded, it's all just a memory. From the memory, we just pass a memory pointer to different stages. So a pre-processing just gets a memory pointer. It works on that. Then it sends to the next stage in pipeline. And because it's a pipeline, when you're working on the pre-processing part, you're already starting to process the next frame that's coming in. So for real time, right? If you real time, when I mean real time, is 30 FPS. N number of streams, you are able to process the entire pipeline in that short window, so that you're able to keep that pipeline full, so that you get the highest throughput out.
Yeah,
that's interesting. And hearing how the memory is handled and all that. So so as the developer who's editing the text file, you don't know it, but underneath the hood, you're manipulating very, very highly optimized C code at the end of the day, I imagine.
Correct. And if you are a developer who actually wants to get his hands dirty, we provide source code for all these sample applications. So you can use our sample application, or you can customize it, create your own application, bring in your own AI model, and do your own post-processing and things like that. So we do provide a flexibility for developers to kind of customize their application as well.
And if folks want to check out a real-time example of an application, I work with developers. They go by the name Smells Like ML. So if you go to smellslikeml.com, you'll see a really cool application called Stilo. They experimented with DeepStream 5.0, and they used the TLT toolkit to fine-tune a DetectNet model. And they basically built this fashion data set to detect jeans, t-shirts, shoes, and dresses. And they use that they use DeepStream basically to deploy a model on a Jetson device to create a wardrobe assistant. So it's really cool actually to see some of the stuff that you can build with this software. So if you check out Smells Like ML, if you want like a really cool application of it, if you're having some hard times during COVID finding which shoes or shirts to wear, like that might be something cool you can check out.
So one of the coolest things that I loved about this project too was that you'd think that it would have been a much bigger endeavor for Paul and I, but I mean, at the end of the day, it was a few hours of work, and no code was harmed in the process of building that entire thing. It was just editing config files. So it was a lot more approachable than you would think building something like this would be if you're kind of you just need the model to run against the video stream and you're not trying to implement your own codec or something. We do have a question from the audience. Mario Moonshine said, is pre-processing the most important part of optimization?
I'll take that. You said is pre-processing the most
important part?
Important part.
Right.
That's one of the component of it. I wouldn't say it's the most important because, as I say, there are multiple pre-processing, and this depends on your input stream. So one is basically you have 1080p stream coming in, and you want to scale down the resolution, image rescaling. That's one thing. And the reason, the thing that we do in DeepStream is we use our different accelerator. I talked about the decode. For image rescaling, we use our VIC on Jetson, which is the Vision Image Compositor, to kind of scale down that image. So that the beauty is that you actually don't use any of your GPU at all. So you keep your GPU free for actual deep learning tasks. So that's why you can offload pre-processing. Other pre-processing is dewarping image, right? If you have a use case, if you have a camera like a fisheye camera or a 360-degree dome camera, you might want to dewarp that image before you run inference. So our pre-processing using various CUDA APIs, we are able to pre-process it efficiently. But to your question, it is one of the important step. And again, like if it's not done optimal, you could potentially introduce bubbles in your pipeline, which could reduce your overall throughput.
I got a question for you guys on the training sessions you've done. Did you dive into the transfer learning toolkit at all?
Almost.
Almost. Okay. I saw you used a pre-trained model, but I didn't catch if. So maybe that was mentioned earlier. Can you maybe explain what the transfer learning toolkit is? And it's part of DeepStream, right?
Correct. Yes and no. So to think of, like, you have in AI world, right? You have the training side and then you have the inference side. So DeepStream is for edge inference on for real-time application. You also have the training side of it. That's where the transfer learning toolkit comes into play. So it's a simple, easy to use toolkit to train your AI model. And again, like the way we kind of position this is like it's almost requires zero coding. It's also just configuring your spec files, choose the network that you want, and bring your own data set, and hopefully the output you will get the desired. Your output is a trained model. There are two things that TLT or Transfer Learning Toolkit has. One is we have this feature of model pruning. And this allows you to really trim down your model. And again, this is nothing new. Model pruning is supported in TensorFlow, PyTorch. And again, TLT actually builds on top of TensorFlow. It's not our own framework. It's just a simplified version of training. So if you're just starting out with AI, it's a great platform. So what pruning allows is ability to really trim down the model. So you can scale down the model by 70-80%. And what we have seen in some of the models, we are seeing about 2x increase in our inference throughput and like 5x reduction in memory. And all of the models are our own custom models, and or not custom models, but our own implementation of a lot of open source models. So we have we support the popular YOLO v3, faster RCNN, SSD, RetinaNet. So all of those are supported in our transfer learning toolkit. And we released a 2.0 developer preview about 2 months ago. And then we are going to release a GA, which will actually end of this month, which will actually support like mask RCNN.
So the reason why we were looking at TensorRT, the Transfer Learning Toolkit, I'm sorry, is a number of things that you hit on. One that I thought was really cool is you can take an existing model and sort of, I don't know, splice it to your model. Maybe that's what you meant by pruning. When, like, you can take, I guess y'all have something called PeopleNet. It's really good at detecting people. And what we could do is use that and sort of splice it with our own object detector that detects people and make it really, really good, because now it's got all the brains behind the NVIDIA, supercomputer trained model, plus our contextual samples from whatever environment we want to put it in. And now we get a very, very highly performed model because it's been exposed to variety as well as contextually relevant samples, giving us kind of a highly accurate and hopefully optimized in terms of its ability to detect when it goes in production.
Yeah, that's a very good point. And PeopleNet is one of our what we call purpose-built, highly accurate model. And what we've actually trained on like million images. So we've done a lot of the heavy lifting. And what we published is it's like more than 85% accuracy on our own data set. Now, as Paul mentioned, it's good on our data set, but you might have a different use case. You might have a different camera angle. So you want to do some amount of transfer learning, but you don't want to train it over a million images, because you might not necessarily have the time or compute resources to do that. So you can do it on smaller data set, with your own environment, with your own adaptation, and then you can retrain our PeopleNet model to detect people for your particular scene. So that's kind of the idea behind the PeopleNet model and also the transfer learning toolkit.
That's really cool. And so, like, what we used a tool called Custom Vision AI from Microsoft that exports in a format called Onyx. And to go a little bit deeper, while we did mention that to wield DeepStream, all you need is a text editor, there's also a whole plugin system that you can build essentially GStreamer typed plugins that wrap around anything that GStreamer can do to perform custom things. So that includes, in our case, we demonstrated building a custom YOLO parser to parse the Onyx files produced by the Microsoft Custom Vision AI tool that allowed us at runtime to perform inference using that GStreamer inferencing backend using models that came from that service. So if you do go deeper, you guys expose everything there. Like, you don't just have to wield the configurator. There's a whole sort of sense of plugins. And I'm curious, is there a community repository of those? And what types of plugins are you seeing coming from perhaps open source developers these days in that realm?
Yeah, so I think what Tenika mentioned on the Jetson community page, on that page, we also have quite a few DeepStream projects as well. And these are community projects that people are working on like really cool things. And we track as many as we can find. And there are a lot that people just create something and they tell us through our forums or through our advocates. And we track a lot of those, and you can find link on our Jetson page for a lot of our community projects. In addition to that, we also release quite a few sample applications, sample plugins on our own NVIDIA AI IoT GitHub page, and I can share the link on that. And there we build like sample application for different use cases. So one of the one of the sample apps that we have is Python, and everybody now works in Python, and Python is widely adopted in the deep learning data science community. So we actually our plugins and everything, the lower level is all in C, because we want to be as performant as possible, but we built kind of a bindings, kind of think of it as like a shim layer on top of the C code, which allows you to actually use a lot of our plugins through Python API. So you can write your customization in Python. Again, you might not get the same flexibility that you would if you were to really get your hands dirty with C, but it does provide you ability to do some of your applications in Python if you so desire.
I think that's going to have to be where I go next. I want to build a GStreamer plugin. We got to get it to do facial recognition and then just add lower thirds. So recognize the person and then just.
So there's an interesting question here. Is that Aaron asking that?
Yes, that's Aaron.
Yeah, I'll let you ask that one, Erik.
So Aaron asks, what are some of the most novel or unusual use cases you've seen for the smallest devices like the Nano? It's like he said, I continue to be amazed at how accessible this is. So yeah, what things can you tell us without getting a slap on the wrist when you get off the stream?
I don't know. I'll let Tenika answer that. I'm sure she has worked with a few folks who are doing interesting stuff.
One of my favorites, goodness, I don't want to get a slap on the wrist, so I'm going to stick with the safe stuff, right? But of course, I got to plug the JetBot. Of course, it's a great opportunity to like entry level get into using Nano, and it's such a fun way to build like those donkey cars, or like AI racers. There we go.
Yeah.
And COVID basically,
those are the next things on my list. I have like tank tracks and all of this stuff for a robot project I started a couple years ago, and
there's a lot you can do with it. But go ahead.
Yeah, we had this big AI race planned for GTC this year, but COVID canceled. We got COVID canceled, so we weren't able to see that through. But I would say the JetBot is a great use case for Nano, and it's a great entry point too for your, if you have nieces, nephews, high school kids, or college kids who want to get involved in building and learning AI. That's a great way to get started, and it's a pretty easy way. It's an easy way to get involved and learn how to use Jetson Nano. Let me think, Chintan, do you have any other ones that come to mind as I ponder some of our projects of the month?
I think a lot of the cool ones are definitely on the robotic side of it. People are doing fun things with like robots or drones. Let me
I saw one very interesting where there was a guy hunting like a squirrel or something that will come to his house, and he wanted to capture the squirrel and just make some noise or something like that. And that was kind of capturing to me because I have a woodpecker that comes to my house and have a new sighting and cost me a lot of money. So I'm like, I got to do something like this too.
Yeah, there was that COVID social distancing one too, that I think they're called Neuralet, but they did one where it was like object detection and it could tell if you were 6 feet apart, which I thought was really cool and a really cool use case of how you could apply even the stream technology and Jetson. Correct me if I'm wrong with the technology on that with Chintan.
Yeah, I think that's correct. I think they worked on a COVID project where it can do people detect, and then based on that they have like a camera calibration software that can tell how far the each individuals are, and they can flag if they are less than 6 feet, for example.
Yeah, that's a cool one. And one last one, it was a winner in our Hackster IO competition. And Paul, you might remember this one, but it was the Weed Whacker. It was the AI-based mechanically weed removal robot. And so on a robotics use case, this one actually autonomously detects segments, and it basically pulls the weed from the crop using AI. So I thought that one was really cool. I'd love to share with you guys a link to it, because once you see the image of it in the video, it's a very compelling use case in an agricultural robotics use case. So check that one out if we get you the link.
So Pete Codes has an interesting comment here. I'm going to reshape your question just a little bit here. Pete says he likes the idea of being able to detect people's temperature. It'd be great to install in places like bars or use as a security system. I'm going to modify your question a little bit to say, I've done some investigation on FLIR, I think is the company FLIR, makes these thermal cameras that basically give you vision, like if you've seen the Predator movies, like you can see the spectrum of heat on an object. Do those work with Jetson? Have you seen an implementation of something like Jetson? And what does that look like?
Well, I haven't seen it on a Jetson yet, personally. I don't know if the rest of the team have. But yeah, that would be the idea. If we can, the Jetson has USB port, right? So it can take a USB signal. So if that's an interface, I was actually going to buy one of those cameras and plug it into my Nano until I saw how much they cost. So yeah. I'm out at $5,000. I'm a hobbyist on that, so I didn't ask if I could expense it. But yeah, and I think I was alluding, I may have mentioned earlier that one of the use cases would be, people counting. So say it's a supermarket, how many people have come in, occupancy, counting how many people are in the store, taking temperatures, is it 1 nano, is it an NX? I don't know, that's the scaling. But the cool thing is if you develop it all on a nano, you can put it on an NX with minimal effort, maybe just changing a config file and tweaking some files, and you can scale it up to as many, however large a device that you need, so if you need full T4s, 2 of them in a store, you can scale there, and your code is still going to be intact.
That's sort of what we ended up doing with the Nano implementation. We couldn't do the inference on every frame of the video and maintain real-time video feed for feedback, but it still works. We can develop on it. We can prove to ourselves that it works before moving up into something more expensive. And then to your point about the FLIR camera, I was also going to buy one. So I have a giant smoker and I love doing that stuff. So I built my own PID controller to control a blower fan to stoke the fire. But I was like, I should get a FLIR camera to determine whether the heat is because of the fire, whether it's just ambient radiant heat or whether the fire is still going. And then I saw the price tag and I'm like, well, that's out.
Yeah, you can get the little one that hooks onto the phone, which I bought years ago. So the iPhone changed their connector. So now I have a bricked FLIR camera that I think you can do an RTSP or RSTP stream off of a mobile device. And I've actually thought about repurposing an old iPhone 5 with that IR camera or infrared and playing around with it. So I actually got it out, but I haven't done anything with it.
So we had a question in the chat. Pete Codes asked, what's the difference between the Nano and the NX? And I'm guessing this is hardware specs, what's available?
Yeah, so the main difference is actually it's a different product. So NX is I would say 10 to 15x more powerful than the Nano. Yeah, so Paul is showing a box of NX. It has a lot more GPU. It has a lot more CUDA cores than a Nano. But the beauty is it's the same form factor. So let's say you start with the Nano today for your development, and then if you wanna, like, this is even for production, right? If you have something developed on a Nano, and then if you want to upgrade to NX, it's just a simple change of our module, and then you go from a much lower or good performance on a Nano to extremely high performance on an NX, with almost keeping your hardware architecture the same. Again, it's going to be slightly more power, so you might have to upgrade your power, might have to get a fan for a NX, but the main thing you get is, for the same form factor, you're getting a lot more GPU power, a lot more computing power. This is all the other things like decode, as well as all the other pre-processing. You can handle a lot more streams on an NX than on a Nano.
Yeah, so from the top of my head, I'm just kidding. I just Google it here. Just looking at the watt performance, it looks like the Nano goes from 5 to 10 watts to the NX, the 10 to 15 watts. So it's just a little bit more power consumption. But in terms of teraflops, the Nano you get 0.5 teraflops versus 6 teraflops in the NX. So
Yeah.
it's just way more speed and
Did you say
power
5
behind
and
it.
6? That's a huge order of magnitude.
Oh, it's a huge jump. Yeah, for sure.
Yeah.
And so we can speak to that because while Erik was developing the solution on our live stream on his Nano, I was making sure everything worked on the NX. So we were kind of developing a solution in parallel, although you just didn't see that happen on camera. And I can tell you that the conversion process, you know, when you talk about porting code, it's usually you think, oh gosh, what kind of nightmares am I going to encounter going from one platform to the next? It's actually a walk in the park. And what you find yourself doing is that when you go from the Nano to the NX, you're actually just going through your configuration and turning everything on higher and essentially just letting it rip harder than it was prior to, because you have all this available power. So the porting is actually negligible. So if you are wanting to get into developing for these devices, the Nano is a great $99 entry point that doesn't break the bank, that gets you the same exact platform. And when you're ready to go, big, when you go to the next platform, the only things you're changing is you're just saying, okay, I want more power, and you get that. The end. There's no real, it's not like converting from ARM to x86. It's just it's a flat conversion, very, very easy, and you leave happier than when you started.
Yeah, but keep in mind the Nano, yes, it has its limitations, but think about it, it's 5 watts. And the chip is tiny, right? So if you're doing hardcore development on it, yeah, you got to crank up to full power. What were some of the other development challenges you came up with? What's your pro tips for someone that gets this Nano in the developer kit? Right, they need an SD card, a power supply. What do you think? I mean, I have my opinions going through the Jetpack myself.
A fan.
My experience.
You want a fan.
Number one, you want a fan.
Number one, when you're training it hard or pushing it hard and driving the robot, mine can overheat. Yeah.
But I mean, really, we're talking about these devices though, and we refer to them as the smaller device and things like that. I'll switch over to I have a capture device to the one that's running right now. I mean, this is a full Ubuntu device. This is processing 2 RTSP feeds. It's doing inference on both cameras. It's drawing boxes. It's providing back the feed to me in video format. And as well as I think it emits its own RTSP feed. And this thing is just fine. I can still use this device. I could write code on it while it's doing this. So it's a small device, but it's more than sufficient for probably what most people are going to be using it for.
Yeah, my fingers are small enough, but this is a system board. System on chip is under this heat sink. So everything around here is the development kit. So that's how small the chip is under there. Hey, I saw a question for level 3 driving. How do you scale it? So you'd want to look at the AGX platform from NVIDIA. They have the drive boards. So there are different scales. So level 3 is a certain configuration with maybe one large GPU, all the way up to a level 5 GPU board, which could be 2 massive GPUs, an 800 watt system board. But that's how you can scale up to self-driving.
Ryan, to your question about like pro tips when developing, I think I did early on with my Nano hit the max capacity, and the task that I was doing was using all cores to compile OpenCV. What's amazing is the device can do it. It requires you to have a fan. If you do not have a fan, you may freeze the device. You can do it. But what's even more amazing is that you can do it and it takes like maybe an hour or two. I challenge you to do that on a Raspberry Pi. I will see you tomorrow. If you do it with all the flags that we had enabled, at least for acceleration and things like that. So it's a formidable device. It can compile OpenCV on the device. What Erik's showing you is it can perform live inference, essentially skipping every other frame in order for us to get multiple camera feeds. And those are live camera feeds. But if Erik wanted to, he could also tap into an RTSP stream that is serving up the same visual that you saw remotely. In fact, that's what I do at home. I VPN into my network, and I can use like VLC to securely access my Jetson that I have plugged into all of the cameras at the house. And it's nice because you get a single view. So these things are very formidable devices. In Erik's case, he's used 2 cameras. I've used the Nano with 4 on Wi-Fi, and it doesn't miss a single frame, which is just fantastic.
Yeah, and that's one thing somebody in chat earlier mentioned too, that they didn't have the same sort of performance problems. And I should point out that is something Paul and I were trying to diagnose. His devices have performed much better than the one I have. The one Paul shipped this to me from a batch he had. So I think that he just, injected some spyware into firmware or something and then mailed it to me.
Yeah, I did find that the low power tiny USB Wi-Fi chip or adapter, that makes a huge difference. So if you have a more powerful Wi-Fi signal or adapter, otherwise if you went to Ethernet, it was just screaming fast. And so when I was training this thing to drive around the house and follow objects and chase the dog and whatever, I just had a 50-foot Ethernet cord on there, and it was flawless. So
tethered.
Yeah. Another thing I found, I got a faster SD card. I got the fastest SD card I could get off the internet. That made a big difference. So just anyone that's wanting to play around, and then the power supply. I think you have the power supply tip.
You definitely want that if you're using a USB powered camera. You want to have, there's a jumper that you can attach onto the Jetson that allows you to use the full 4 amp input if you have a 5-volt 4 amp adapter. The amps are important because when you plug in a USB device, it's going to draw more amperage from the Jetson. And I definitely know on the earlier models, I melted one temporarily because I was plugging in the USB without having the jumper set. So it is a requirement. You will overdraw on the device if you don't do that. But the other benefit is once you attach the jumper and the appropriate power supply, you can scale from the 5-watt power to the 10-watt power mode, which gives you more performance during, if you're running deep stream inference loads and that sort of thing. It'll actually run faster in those cases.
And so we've been talking a bit about deep stream and kind of video analytics and things like that. But overall, I'd like to kind of talk a little bit more about like the intelligent edge and the types of other things that people could use these devices for. I guess this is still a little bit video, but in manufacturing pipelines, can we detect flaws in things right on the line and things like that? What other types of use cases could we use these small devices for?
Yeah, I think so again, as you said, video is video or images or pixel data is kind of ubiquitous for all of these type of tasks. So for factory, I think that's one place where you can use video or images to find defects, and that's actually one of the important use cases for intelligent edge, where you might not be able to connect to a cloud or a server in some remote location, or where you can process some of the information right on the edge, figure out if there are defects, and then send that information back to the cloud, and from there you can do further processing. So the other use cases are like smart factories, construction sites, and again, and those are a lot of those are in remote location where the connection is to cloud is quite bad. So there you really need that intelligent edge to generate some amount of analytics, and you only use the cloud for sending the information from edge to the cloud. Going beyond like video type of use cases, right? There are other use cases for AI, and again, they could be on the edge or they could actually be in the cloud, and they are type like applications like NLP, natural language processing, or text to speech, where you want to convert the text, or where you want to convert written text to speech, or vice versa, speech to text. Language conversion, for example, if you want to convert from English to Spanish, or things like that. So for those type of applications, it goes beyond just kind of video use cases or edge use cases to more audio or natural language processing type of use cases.
Yeah,
That's
and
a
I
good
think
point. I saw the Jetson 4.4 ships with a demo that almost all those things you were describing, plus some more, are included there, where it can do like text to speech. It can do wake word analysis. Essentially, you could turn it into an Alexa of sorts. There's also a cool gesture pose demo where it's not just showing you an object being detected, it's showing the bone structure of a human being and where their pose is, which I'm sure helped with the mixed pose application that Tenika was mentioning earlier. And that's just one of the built-in samples on the device. So, which would be an interesting segue. So like, if you don't know where to start, the samples that ship with this thing are actually pretty cool.
Yeah, I think you brought up a very good point. So with Jetpack, which is what runs on our Jetson, we 4.4, when we released it a few months ago, we released 4 containers on NGC, and they do different things. One is just a deep stream container, does people detection and people counting, and the other cool ones were pose estimation. So real time pose estimation, and it can basically render your joints on your body, and as you move, it can actually change, do pose estimation in real time. Other one was gaze estimation. So think of a use case could be you want to you want to engage a kiosk or something, and like if it's if you want to engage both your with your eyes as well as your when you start talking. And a lot of, I mean, currently the system that we have is you have to say that word like, hey Google, or hey Alexa, or whatever, to engage that. But this could be like you look at the camera, and camera sees that, okay, you're looking at it, and then you start talking, then the camera knows it's actually like interacting with another person, right? When you interact with another human being, you don't say you just look at that person and start talking. So it's kind of like that. So what our demo does is it sees somebody is looking at a person, and then you all the 4th container is actually I believe it's a speech one. I'm not exactly sure what exactly it does, but you can ask a question, and it will return back an answer. So
you're talking about the Jarvis SDK. So
this is
a lot of those
correct.
pre-trained models are in there.
I like how the robot one is called Isaac, and then the voice one is called Jarvis. That's
Jarvis.
Yep. And then Clara is medical.
That one.
We've got them all.
No,
Drive is autonomous.
What's Big Hero 6's name? That's the name. Oh, why can't I think of his name now?
Asimov?
May. The other thing that Chintan mentioned is NGC. So for people who don't know, NGC is our registry. We have a registry of containers where we store a lot of our models that we optimize, and for people who want to just try it out, some of these on solutions, kind of plug and play. You can just easily go there and browse through a lot of different use cases, a lot of different models. They're all containerized, and it makes it very easier for people to get started as well. So I think when you guys were doing the nano stuff, I'm not sure, did you download any containers? I don't remember. I think it was preloaded.
This is a great topic to focus on. Before we do, I do want to mention the gaze estimation. We need to add that into these e-learning systems that are no doubt going to be needed as we move into the second half of the year to tell if people are paying attention in class in their Zoom meetings with their teachers and stuff. But yes, NGC, so that stands for NVIDIA GPU Containers, if I understand. And that's a huge, huge, huge technological innovation. The support for GPU workloads on containers.
It is. So I have a container background. That's actually the area of tech I focus in the most, is containers. And yeah, GPU and real-time clock related things in containers has traditionally not been an easy task.
So you're telling me I can write an optimized program that leverages a GPU workload and distribute it in that same beautiful fashion that Docker allows of it'll always work wherever I deploy it, provided, of course, that GPU is present, where it'll just work on someone else's machine, essentially. Y'all have encapsulated GPU support into that paradigm, and I just feel like that brings a lot of things with it. Like if we're talking about edge workloads, you're thinking smart cities, and maybe you want to deploy something that, let's just say, does something like detects if vehicles are stalled on the highway. What if you want to send updates to that? How hard is that traditionally? Traditionally, it's very, very difficult. But with the concept of containers, we can send layered updates that are, let's just say, more or less guaranteed to work once they hit the device. And this gives you that awesome ability to just distribute and package up an application that I just imagine would be hard if these facets and mechanisms didn't work, if not impossible. And think about this from a Kubernetes type of standpoint. Like you could also be deploying, say, redundant GPU workloads to multiple types of hardware. And I think someone mentioned that in the chat, that we are starting to see people are building clusters with their NVIDIA hardware at home. Like,
yeah, if Paul didn't cheap out and sent me more, I would have built a cluster out of them.
Yeah, actually, just on a side note, somebody has worked on a project where they use, I believe, K8 or K3, the Kubernetes, to build a cluster of Jetson. So somebody has actually have done work on that front. But to your point, I think container is an important step for us. I mean, we realize the flexibility of containers to containerize an application where you don't have to worry about all the different dependencies. You can all package it in a container, and we have containers for our x86 GPUs, and these are like our T4 V100. And they run all on an x86 machine. And then we also have containers for a lot of these projects, like all the Jetson container demo that I talked about earlier. They're all available in individual containers. So you can just take one, you can take two, you can take all four. And those are all compiled for our ARM architecture, which is what Jetson runs on. So it's an extremely important step for us, and as Jaime mentioned about the NGC, a one-stop shop for getting your containers, and we're adding more and more containers. So I think we have for DeepStream, we have container on both of our Jetson platform as well as our DGPU platform, and we have multiple variants of it depending upon like what do you want to do. You want to develop on it, or you want to just take it, do some configuration file and just ship it, deploy it. And then we also have a kind of a Kubernetes deployment example on NGC where it shows how to take a container from NGC and deploy it on a pod on your cluster.
Yeah, so we have some help charts too. So that's not only the containers, and And
Correct.
we have models, we have Helm charts as well. That some of the pods that
What's
we
the
can
coolest thing you can do with a clustered deployment of an NGC container to a Jetson device? Because I've got 20 of them behind this door, and like I've got a lot of time this weekend. So give me an idea here. This is
You've got 20 and you
Also-
sent me one. Come on, Paul.
you're getting 10. Don't worry, I'm splitting this with you.
So I think for me, so we have another thing that I'm working on for Helm charts for Kubernetes, but it's more of like a longer pipeline, right? Like the pipeline you guys made is just a stream of cameras, and you connect with Microsoft very nicely. There's a nice plugin, but as you add up, let's say you're doing an open source stuff, if you want to do databases or Kafka in the middle, or if you want to connect other technologies, Elasticsearch, or if you have a UI in the middle or something like that. So those things can be basically put in containers and Kubernetes and sort of just have a Helm chart and easily be able to deploy those things whatever you want. And so for me, it would be more of a longer pipeline, but I mean, nothing will stop you from expanding, vertically or horizontally. I mean, that's the whole point of Kubernetes, right?
We can always start with a Helm chart containing a Grafana deployment and Bitcoin miner. We'll start there. We'll start simple.
Yeah.
So we had a question earlier in the chat I want to talk about. So this is more like personal, hobbyist home electronics stuff. Yoda Droid asks, like, how good would the Jetson be as a streaming PC for something like doing Twitch? Like, can we run OBS on it? And that's actually a really solid question, right? Because a lot of people don't want to have to try to run OBS and all of this stuff on their laptop or something if they're streaming. And I don't want to buy two computers, but $100 Jetson seems like it might do the trick. I would assume that it would run it because I haven't tried this, and if you're really interested, shoot me a whisper so I remember. But I'll try that out this weekend and see if it works. But I would assume the hardware video encoder would work. Yeah. If it's just running OBS, the Nano has 4 gigs of RAM on it. So
Yep.
Yeah, it should work. I mean, technically we can run up to 8 streams on Nano, right? With deep stream, so you should be able to. I mean, it has enough encoding hardware encoding capacity to do 1 stream. So I don't see why it shouldn't work.
Yeah, it just depends on how much RAM OBS itself uses.
Yeah.
And for our streaming session, Erik actually, he didn't run OBS itself, but using a browser tool called obs.ninja, he was able to stream his device. So this isn't exactly the question you've asked, but you can stream the device to an OBS source if that's what you're wanting to do. Instead of running OBS, say, on the device, you can actually do it by just visiting a browser plugin. In fact, that's how you're seeing us right now. We're all tuned into obs.ninja and fanned out into the Twitch sphere.
So I think what the idea would be is to leave your device itself free from running all of the encoding software. You'd probably use like a video capture card or something to send your screen out over HDMI and then bring it into the Jetson as an input and then do all of your encoding and packaging and stuff like that and stream it RTMP straight from the Nano. If I'm understanding what Yoda Droid was looking to do, I think that's probably what they were shooting for. I guess you could use like this is probably a shout out to an individual provider, but you could use like an Elgato Camlink, which is an HDMI to USB adapter. So you could plug that into your Nano, and that's how you could get your HDMI into it. Yeah.
What if you just connect a USB camera, a webcam, and
so you could do that for the camera part of it. I think what they're probably looking to do is also to stream their screen from their development machine and get it into the broadcast software.
Like video game consoles, people love doing that. How do you broadcast your retro gaming setup? I know there's a lot of that on Twitch.
So how about this? I'm gonna make some promises and hold me to it, Yoda. I've got some free time this weekend. I have a Jetson Nano, and I have a cam link. Let's see if we can make this work. Maybe I'll go live on my personal Twitch over the weekend, and we'll see if we can get it working.
Yeah, that would be nice to try,
Nice.
because we have a lot of those technologies for the GTX GPUs, right? They're more for traditional graphics cards, and you can do all kinds of things in the background with those cards. You can put a background that you're on the beach, or you can do all kinds of little tricks, especially for people who want to do these type of things, like streaming your own game, and or doing YouTube stuff, so Twitch or whatever. So, but yeah, that'll be nice. Please keep us posted.
I wonder if you can do TikTok with that. You can show us a little dance or something while you're at it.
So I used to be able to dance. I was in a motorcycle accident and had shattered my femur in 12 places, and I don't dance anymore.
Okay. good reason not to dance.
I think we can teach you to do the floss. That would be the simplest dance.
Yeah, I still mess
It's
that up.
The only one I know.
So there's an interesting mention here. Someone brought up GPU support came to the Windows subsystem for Linux. And just to fill y'all in, yes, hell froze over a few years back, and there is a Linux kernel that ships with Windows. You can run essentially distros on top of the Windows OS, or should I say side by side with it. And those have traditionally been hampered by one missing thing: you couldn't do GPU accelerated workloads. Well, that is all changed now. I think this was announced at Build. And I haven't taken this for a spin. I don't know if anyone on this call has, but feel free to share your experiences. But doesn't that theoretically mean we could build deep stream workloads on our big boy laptop machines and maybe shift those down to the embedded device? Is that a possible dev pathway now, where you could build on Windows and then deploy down?
It's actually interesting to think about. I may be speaking out of turn here with how this works, but my understanding is somehow the GPU calls get mapped to DirectX on Windows. I think that's how it's implemented. I don't know.
Yeah, good. I just haven't tried it. Does anyone know?
I haven't either. I read up on it, and now I would say it with like CUDA supported through what's it called, Weasel, right? So it'll be interesting to try. I don't think I have tried it. It'll definitely be a very cool project to try. That, hey, by the way, you can just run these X, Y, and Z applications like DeepStream on your Windows machine that has a RTX card or GTX card, for example.
Yeah.
I started and when it was on preview. Is it still preview?
Yeah, I don't know that it's
GA?
I don't even know that it's available for everybody. I don't know that I could find it. If you follow
I want to say it's a Windows Insider.
Yeah, I don't even think it's.
I see public preview here. So
I've seen the announcement even from the NVIDIA side. So I've seen it on our CUDA developer page as well.
And
I started to install all the drivers and everything to get it going, but it was on my gaming PC, and I started to get a little hesitant to keep going.
Oh, yeah, you thought it might Minecraft or what?
So
yeah, I had to get RTX.
If you're interested in that stuff, Hayden Barnes on Twitter, he's in the DevRel team for Ubuntu, has been doing a bunch of this stuff with GPU related stuff inside WSL. I'll link his Twitter in the chat, but follow him because I know he's been doing some projects related to this.
Yeah, I'll jump into the WSL once I get back to playing with it, and I think it'll make life easy, so I don't have a dedicated Linux box.
So speaking of announcements, so DeepStream 5.0 was announced at the most recent GTC event. What are the big killer features in DeepStream 5.0 that like have yet to hit the mainstream, maybe because folks just don't know about it or aren't aware of it? I just know personally there's things like bidirectional support. I don't know exactly what that means. There's also something called the Triton Inference Server, which sounds really, really cool, just from cursory review. Do y'all want to maybe go into some of those updates? What's in this latest DeepStream release?
Yeah, I can take that. So yeah, we actually released a DeepStream 5.0 kind of a preview version, developer preview, end of April, and we're about to release general availability most likely around like end of this month. And developer preview, I mean, again, it's open for everyone. It's free to download, so you don't need to be on a separate list or something for you to get that access. So the key features, I think one you mentioned is support for Triton. So Triton is our NVIDIA's inference microservice, and it was originally designed for our x86 data center type of GPUs, but now some of the features are kind of adapted to work on our Jetson platform. So the main benefit it offers is now you as a developer, if you are working on your killer AI model, you can actually just leave that in the training framework of that you're working on. So if you have a TensorFlow model, you can just leave it in TensorFlow GraphDev, or PyTorch model, you just leave it in PyTorch and use it directly with DeepStream. So prior to this, for your model to work with DeepStream, you actually have to convert it to TensorRT, which is amazing. I mean, it will give you the highest performance because we do a lot of optimization on the model, create a runtime, which fuses a lot of the layers that gives you the benefit. But I mean, it's a lot of times it's not trivial. So if you have a new model that is just out or that is like state of the art, you might have to do some custom. You might have to create some custom TensorRT plugins. So now with TensorRT, you can actually prototype on your model as it is and run inference in Triton and use DeepStream to do all the other things like decode, pre-process, and post-process and things like that. So that's one key feature that we have. The other one, bi-directional messaging, and again, I think we're kind of working on this bi-directional messaging. So basically, before 5.0, you can send one way, so you can send it from your edge device to cloud. But now that's important. That's definitely important. But you also want to be able to receive messages. So think of it like, you know what, you have you want to record something of interest, and you want to be able to receive a message from the cloud that says, okay, now this is of an interest, please start the record. So cloud sending messages from the cloud to your edge allows that, or receiving messages allows that level of control from the cloud. So you actually don't need to be physically connected to an edge device to do something. And I mentioned about the recording something. That's another feature that we have called Smart Record. So we run a Smart Record API with our DeepStream application, and what it does is you can actually selectively record when you want. So you might have a certain scenario that you want to record. So you can say, okay, I need to record at this time. So you send a signal, DeepStream will only record it for that finite amount of time. So this allows you to save disk space. You don't have to just keep on recording for 24/7. So those are some of the key features that we have. There are a lot more that I can go into, but I'll probably just stop at that.
That's amazing. So just the offsite recording feature is cool. It's almost like, I don't know why I buy the cameras that I buy. Let's just say that, because once you slap DeepStream on it, it gives you all these other features that these, I'm just, when is the mainstream cameras going to adopt DeepStream on their actual runtime? Allow me to do offsite backups, allow me to do triggered recordings, or maybe change the model as it's running.
As soon as they adopt good security hygiene first.
Yes, they do miss that. But you hinted at something really interesting with Triton. It almost sounds like that democratizes or gives you this choice of what model framework you want to bring to the Jetson platform without impeding you through some sort of unnecessary conversion. And Erik and I hit this in the very first module. He asked the question, wading into the waters of ML, like, okay, so what's the format everyone uses? And it's like, I got bad news. There's no format. There's no standard. In fact, it is like a Rosetta Stone. There's a project out there from Microsoft called MSDNN that attempts to map those things using an intermediary layer. So like it'll go from cafe to some intermediate layer that you could then transform into pandas or keras or whatever. And it's kind of a nightmare at the end of the day. Like you see, it's almost like it's limiting in terms of, it's a shame that there's not a common standard, I guess is what I'm getting at, because you now find that you're unable to work with people because maybe they're, tied to a particular platform, and it's really gotten out of hand. I think last I checked, there's at least 15 formats that I'm aware of. There may be twice that many if you looked at them all.
And that's why you have the Onyx, representation and Onyx runtime, right, to basically mitigate a lot of these problems. But this is something, kind of relatively new that people try to do to mitigate this, problem. And you're right, it was pretty funny seeing you guys when you show Erik like the mapping. You have like 10 frameworks and other thing frameworks. So how do you, if you train your model on these frameworks, then now what, right? Like you're pretty kind of limited to kind of like your framework. You're kind of stuck there. But slowly, I think people are, coming out of that and realizing that we have to have something in the middle or standards or something. So
I was actually really surprised to find that out, being new to AI and ML. Because you're used to, people entering, say, programming, and what programming language do I learn? And you're like, well, that depends on what area you plan to develop code in. Except ML is a focus area, and you're like, which format do I use? So, yeah, it was quite interesting to see just how many. I mean, I knew there were a couple. I didn't realize there were that many. And
you realize this in a very short period of time, since the neural networks is basically kind of 2012, basically when you start getting the great performance on the numbers and accuracy, and from that point to now, just exploded into all these different languages. I think even more than what you're talking about, like computing languages, right? Like you started with a lot slower with C, or and then slowly start to. And now you have a bunch of them, but that's over a very long period of time. But this is like, in, I don't know, 6 years or so, you just have an explosion of models and multiple algorithms, and eventually it will settle eventually. But who knows? For now, we're in that stage.
At least you have the tools to convert and migrate, so it seems to help mitigate that.
We'd have the tools, but it's not always easy for someone who's just starting.
It doesn't always work.
It doesn't always work.
I think the interesting thing will be we've seen this before, and in fact, one of the technologies we just mentioned, containers, right? Like there were many, and then we sort of, at the very least, started adopting this common abstraction that we could talk about these things in. So maybe we can at least get there, where if you need a very specific feature of this particular format, then you can use that. But if you're just trying to generically do stuff, then tools work against this abstraction rather than the individual formats. Maybe one day.
So Ian mentions an interesting point. Because of those conversions, you also end up in this situation, which this is both a good and bad thing. I think this brings pros and cons, where the data scientists building the models may end up using a different language or approach than the productionized model that ends up getting deployed. And
that's not optimized.
Skepticism to me. Are you sure these things convert one-to-one? Like if I convert from one model format to another, are you sure there's not some little thing that's getting pruned out of there that it changes it slightly? And how do you prove if it does or doesn't? It seems hard.
I don't think there is a method. Like I don't think you can go from one format to another without really like sometimes going down into details and doing some amount of customization.
Yeah, it's interesting. So was the Triton inference server created to address this issue? Was that kind of the problem, that I guess you don't want to keep adding support for one different platform as these choices are growing?
I think that's correct. I think it was kind of the Triton was probably created so that you can just deploy this Triton container on a cloud or on some data center, and then all you are doing, like like the original Triton or what you can download Triton is just like you send like HTTP or gRPC requests to the server, and what it does is it returns back your inference results, and there you can choose whatever method you want to do your inferencing in. So that's how it was kind of a design that like people there's like as you said, like, there's like 15 different framework and people use different frameworks. So we just wanted to create this common interface in Triton so that you can keep your inference engine in whatever framework you want. It's just that API is common.
So we have a couple of questions in the chat here. One of them is a very, very good question. So Pete Codes asks, are the Nano and NX recommended for production use cases, or are they only for dev? What's the prod use case? So are these just development kits that are meant to do things that we often see in the embedded world, or are these devices that are actually, if I cracked open a router or something, might I find a Nano in there?
Yeah,
full production. And yes, we hope you find NVIDIA chips in these devices. So we're only talking about these developer kits. This is the form factor, the box that he's got there. The developer kits come with the carrier board and all these connections. So if you were to buy a production chip for the system on chip, it would just be a little Nano chip. And then you'd have your connector design around that into the carrier. Build your own carrier board, leverage one that's built by another manufacturer. But yeah, full production. All these use cases we've talked about are production for Nano.
Yeah, and so I guess the question to Pete would be. Oh, go ahead.
Sorry, one thing I would like to add on that is that's correct. It's for production use cases. So, but like the dev kit that you get with the carrier board, those are only for development. Those shouldn't be used for production. And for production, we have what we call a SOM, or system on module, which is just this credit card size, like a board, which has and it's basically, you can actually remove it from your dev kit. But it's just that it's a production quality. And all it has is a Nano or NX and few of the other components, and you'll have to build your own carrier board. But for production, it's a different module. You cannot just take this dev kit and remove the module from there and use it in production. That's not recommended from us. So there is a production module that you can buy.
And I assume ruggedized hardware and cases and stuff to supplement that as well?
Correct. We actually, again, we don't necessarily ship. We work with our partners. So if you have a need for ruggedized hardware, we have partners who create this ruggedized solution. We also have industrial grade our SOMs or system on modules that has a slightly different specs. I mean, the underlying hardware is the same. It's just that we spec it differently. So that's the industrial grade. I think we rate it as like an I for industrial. So those, you can buy those as well for industrial type of use cases.
Got it. Okay, that makes sense.
And Pete asked if they have a TPM.
Yeah.
I think we do, but I'm going to stay away from that one. I am, because I don't know all the details of the Jetsons, but I think that we do have TPM, but I'll probably just say that and leave it at that. So I'm guessing you're talking about security, right?
Yeah, that's my guess, is he's talking about the trusted platform. Yeah.
Yep. Okay.
So Pete also asked, but the code is essentially lift and shift. So if we were to write for the dev kit and then move that to the SOM, it would just work.
It would just work.
Yep.
Yes. Correct.
Yep. Excellent. And lots of comments coming in here. Hard to keep up with them. So one of the things that I've noticed over the years, I've been a fan of the Jetson family since the TX1 came out. And it seems that it's always growing, and that every time it updates, the devices either get more powerful or more smaller or both. And for example, when we were talking earlier about the NX, it's like 10x the processing power of the Nano, but approximately the same size. So is one of the things that's creating the paradigm of, let's call this artificial intelligence of things, would you say that size is one of the contributing factors here? Because obviously we could put a data center class device anywhere there's a power socket to plug it in and an internet connection. How is specifically talking about the size, how is that changing where AIoT solutions are going? And I'll just probe you with, are there any car manufacturers perhaps that might be interested in adopting Jetson?
And did you just say AIoT? Is that a term I've missed?
It's the new one, yeah. So it's the artificial intelligence of things. You don't build IoT without AI anymore. So,
is there like just invent that today? That's great.
Is there like a notification?
No, it's been thrown around a few times.
Yeah. It's been out for a while.
Okay.
Can I subscribe to a newsletter? I like the buzzwords and terms I'm missing.
Alert! There's a new one. Yes, the 4-letter word of the month is AIoT. So yeah, how is the size particularly changing things? Because I heard you might be inside of vehicles. If y'all want to go into that.
Yeah, I can speak a little bit to it. I'm not focused on the drive platform, so it's not my expertise. But yeah, there's different levels of chips, just like you see on the EGX platform or with the Jetson family, different size and form factors, different performance and wattage and thermals. So really that's the gating factor is how much room do you have? How much power do you have? Cooling. And we do have chips that scale or, go up in power, right? So that was my example of the full in-car, an 800 watt dual proc system for level 5, or you have the smaller chips, and I don't know if it's going to be the Nano running your in-car entertainment system, right? Running Jarvis. So, and we have that video online of 2 people driving down the road having a gaze detection to the camera. The AI is keeping track of the conversation with each individual separately. So one person can ask a question, receive an answer, and the conversation can actually go back and forth. And the computer or the AI is keeping track of those people's conversations. So that's that platform, right? An SDK. So really, it comes down to the form factor and the design requirements. But there is something to fit.
But it's just amazing to me that you can even do that, because like you wouldn't put an RTX in a car, but you can put.
May not be an RTX.
But, all right, yes, you can. I'm not saying you can't, but this form factor seems to be the thing that's unlocking these use cases that traditionally were not possible. Like what you're describing here, I really believe that. I think there's a huge thing, just that size, because what happens when we hit the peak of, we saw this with cell phones in the last 20 years. Many of us, I'm not going to say everyone on this stream, but many of us here saw that advent where all of a sudden my Dell 750 Latitude from college is now less powerful than my phone. And so what that starts to apply is, when am I going to have a wristwatch that has an NVIDIA GPU in it? And what the heck is that going to be doing?
It's a good question. On the roadmap.
The other thing with the autonomous vehicles that you mentioned is not only like you're talking about just the inference and the section, which is obviously very important, but if you think about the whole pipeline that it's involved in an autonomous vehicle, from capturing video and then basically being able to train any new environments that you encounter. So you have to send a lot of information up to the cloud and have a system in the cloud receiving and processing all these potentially new use cases, you find a dog crossing the street that you've never seen before or something like that, right? I mean, those things are going to be happening for years and years until you encounter all the possible situations. So there's this constant communication and infrastructure and accelerating computing that you're going to need, just this huge pipeline that you have to have communication between your vehicle and the models that are being trained somewhere else and pushed back and forth, and the data being transferred. And so remember, as one of the things about doing inference on the device is that you can actually capture just the information that you need. You don't have to keep piping all the data back to the cloud, because that would be just crazy. But you can just capture just kind of things that you want to. And then if you said, you know what, I actually do want to capture the whole use case, that dog crossing the street that I never seen before, I do want that, right? So I want, send me the whole video so that we can retrain the model. And so all these interactions with autonomous vehicles are very interesting. And I think we realize we have a lot of pieces of those puzzles because we have accelerated computing on the cloud and on devices and also on the edge. So it's pretty exciting area.
So I have a request to answer Paul's question about if we get a GPU in the watch. I finally want one of those holographic watches we've seen for ages. I want it to project Paul's face when I'm talking to him.
Okay, is that the next Jetson Community project?
That's on our roadmap.
Okay. Hey, we're not that far from that, because just to let everyone know, the NVIDIA Tegra platform is what powers the graphics on the Nintendo Switch, and that's a pretty small thing. It's not quite a watch, but that's something I think all of us have seen. If you've seen the graphics performance of what you can do on a Switch, it's a current gen gaming console that you can hold in your hand. It's powered by NVIDIA Tegra at the end of the day. So that's just...
Yep. Yeah, that's a fun little toy. And then you got the Shield as well. That's the
Shield.
That's my new favorite device over the TVs. So one thing we haven't talked about is 5G.
Oh, yeah.
How's that going to change what we're working on nowadays? I mean, we have the aerial SDK, and we haven't talked about that at all. But Chintan, where do you see 5G coming into play and changing deep stream? Or will it?
Yeah, actually, that's a good question on that. So 5G will increase the bandwidth that we can send over the air, right? So now, if you imagine a smart city, right? I mean, again, like right now, we have barely touched the surface of it. Now, imagine a city like San Jose, which is where I'm located, or Seattle or Houston. They're huge cities. Once you try to aggregate all the cameras and you want to send all that information, you need an extremely high bandwidth wireless connectivity to send all those video data or all those metadata that you collect. And that's where I think 5G and video analytics will come into play, is to make our cities safer and smarter.
And so, speaking of 5G, we actually had a mobile-related question. So, Riddicky, I guess is how you might pronounce it, asked, when will NVIDIA create products for mobile phones? Is that something that you think is being worked on? I don't know whether any of you, like, obviously NVIDIA is probably a very big company with many focus areas.
That sounds like an NDA question.
Yeah.
I would just say that we have worked on in the past. That's all I would say. In the past is like 5-10 years ago.
Wait, there was an NVIDIA phone?
Oh, well, actually, Tegra started as for a mobile phone.
Oh, okay.
Yeah, but
that could do it. Right now, we're going to call it the Nintendo Switch.
Nintendo Switch, yeah. I think
all you have to do is just add a card, right? A SIM card to make phone calls from the Switch, and then you can probably do it.
It's like the Microsoft Zoom.
Get it to run Linux. I'm sure you could pop Android on there and make a Wi-Fi call if you really wanted to.
Well, you have Android on NVIDIA Shield, right? Or which is based on our Tegra.
Riddicky wants you to know, Chintan, that you are the best.
Thanks.
Multi-emotion following that. That's very kind of you, Riddicky.
That's how we feel about Chintan too.
Thank you.
Yeah.
Hey, Paul. So on your, I got a question.
Oh, go
for
ahead,
you, Paul and Erik. Have you guys run across the object detection toolkit?
No.
ODT.
From NVIDIA?
I'm not down with ODT. No.
Okay, Chintan, is that part of your project, the object
It's
detection
not.
toolkit?
It's not actually, but I have looked at it, and it's actually being developed by a few of our SA teams here at NVIDIA, and I think they focus on specific use cases like rotated objects and the ability to
Right.
train detection. I mean, you can probably talk more about it if you know more.
No, I just ran across it earlier this week, and what was interesting about it was the accuracy increase when you set the bounding box able to rotate
Right.
around the object you're detecting, and the efficiency was extremely high as for, versus an axis aligned model, which is just a square bounding box. So I thought that'd be interesting for you guys to check out.
Yeah.
Can you plug it into the deep stream pipeline?
Yes.
And
In
how
fact,
does it?
I believe one of the SAs who have worked on or developed this object detection toolkit have created a plugin for DeepStream or is working on it. I'm not sure if he has or not, but he's definitely working on something that will take one of those ODTK models and use it with DeepStream.
Yeah, that may help your SUV detection, Eric, to where it's not a train.
Yeah.
Yeah. So there's also a very distinct angle at which the camera can face my desktop and see my keyboard angled with my monitor and call it a laptop.
I don't know if it'll fix it, but I thought when I saw this. So yeah, I'd be interested to see what you guys can do with that if it's ready.
I think the interesting, a lot of the combination of all these models are, I think you guys touched also on those and the primary and secondary models where you detect an object and then the secondary model sort of, takes that information and does something else, etc. So I think there's all kinds of combinations and use cases like this. We know we have partners or a lot of people who are working on, for example, being able to identify people and re-identification of people, right? So you get into a store and as you move on from cameras to cameras, you already identified that this is a person, obviously. So, but can you re-identify that is the same person and follow them through the entire store from multiple angles, multiple cameras? So, there's all these interesting use cases. Speaking of those use cases before, so
that's one of the
we'll
things
see
we
what
discussed too, the difference between detecting is this a person and which person is this, and kind of the complexity of that.
Classifiers versus detectors.
Yeah.
The other one.
Yep. And so we have the question in the chat. Seth asked, what kind of models can we run on NVIDIA Edge devices? And I know which ones we played with, but I'm going to leave this open to all of you so that you can fill in.
Well, with Triton, everything almost. I think, yeah, Chintan, if you want to take that one again.
Yeah. So I think everything would be a very generic answer, and I mean you can practically run anything on our devices, assuming that assuming that you have enough computing power. So for object detection, I think from DeepStream side, we actually provide like a turnkey solution for like things like YOLO V3s, all the popular YOLO model, SSD, faster RCNN. For classifiers, I think all the ResNets, InceptionNet, and all the popular ones that we support. Mask RCNN is something that we're going to support, that we'll have a support for when we release our general availability. So these are the ones that you have a turnkey solution. Now with Triton, you can actually take any models from, like, let's say open source Model Zoo and run it with Triton and DeepStream. And that's something that you can do. And again, there might be some amount of customization that's required. Maybe if you have a model which we don't provide post-processing, we have hooks to create your own post-processing to add it. So that's always a possibility. And all the sample apps that we provide, right? Like for YOLO, V3, Fast RCNN, we provide source code for it. So you can look at those to kind of come up with your own post-processing, pre-processing that you require. So in short, you can practically run any model, assuming that you have enough computing power. And second, you just have to make sure that you are able to do a lot of the pre-processing and post-processing that's required to process those models.
Yeah, keep in mind across all the NVIDIA boards, and processors, it's the same platform. So we don't have different platforms as you move between the different families of products, from Drive to Jetson to medical, the specialized devices, whatever we have, it's one platform, right? So if you can write it on one device, you can get it on another device. You don't have to go learn, some other manufacturers may have 2 or 3 different platforms you have to learn for all their devices. So it's extremely helpful.
Yeah, I think that's a very important point that you mentioned, right? Single architecture for all NVIDIA platform, right? So take a Jetson, which is an ARM based with an NVIDIA GPU versus like a larger A100. You can practically run, again, like the main thing is like you cannot run on those large NLP or BERT models on Nano, but you can run a lot of the other models, and you so you have that portability across all the different platforms with NVIDIA architecture, and even moving forward, right? We release our Ampere A100, and all the work that you did on B100 or T4 will just work on A100. So that's the beauty of having this single architecture.
So y'all, we've had so much fun. I don't know if you realize this. Almost 2 hours has passed.
Yeah.
Yeah.
And we've actually had some steady viewership. I think we've been keeping it between like 40 and 50. We're at 35 right now. So this is the crew that's really with us, or that didn't have things to do on a Friday. I do want to make sure that before we close out, we want to make sure that people know where they can go to learn more about all of the topics that we discussed today. And also where people can go to be in touch with everyone on this call, because I know quite a few of you are very social and online, have big online presences. So let's start with we'll go around, share your Twitter handle if you have one, and leave us with a lasting thing that you'd like us to check out, and we'll get that URL posted in the chat as we go around.
I'll get started, and you guys can follow. So I guess I will bring in. So if you want to move, what to do next? One, I'm sure there's a bunch of links that that we work with Paul to have available to you guys, GitHubs and other links directly to, DeepStream and Nanos and stuff. But there's also you guys also can go to our Deep Learning Institute. It's basically kind of like a Coursera kind of thing, but it's only for NVIDIA products. So if you want to learn something, take a course, check out a webinar or something like that. It's a good place to go. So that's one place. You can always find me on LinkedIn as well. So thank you, Paul, for having this call. I really appreciate it.
Thanks for being on, Jaime. All right, Chintan.
Yeah, well, this was wonderful. Yeah, thanks guys for having us. This was I didn't realize that we've been chatting for almost 2 hours. But I would say this. I think what Jaime mentioned, right? The Deep Learning Institute has a lot of a good resource if you want to learn more about Jetson. And in fact, we have a course which is a free course on our DLI, which is getting started with Jetson Nano and getting started with DeepStream on Jetson Nano. So those are 2 of the courses that you can take. And I believe we worked, like Paul did some work with the DLI team for our GTC as well. So there's a lot of resources, and and this was a fun event. I enjoyed it. Yeah, and thanks again for hosting us.
You bet. It's been our pleasure. We'll move over to Ryan.
Yeah.
What we should.
I'm still online. My video is going out on me. I'd say watch all of your videos first. So I'd say the IoT show and all these streams are just invaluable for people learning the platform. So absolutely awesome series. You and Emmanuel do a great work, job on that. So the guys already mentioned what I was going to say. I'd say, if you want to take a more autonomous vehicle approach to learning, try to look at the JetBot or something similar, and then you can also do the other intelligent video analytics as well. But Microsoft also has some pretty good training online for IoT Edge. Even have the AI Business School. Some pretty cool courses on there. I've gone through a couple. So I'd take a look at those. And yeah, I'm on LinkedIn, Brian Huff, easy to find. But thanks for having us. It was pretty fun. And everyone on chat, it's a good conversation.
Awesome. Tenika, tell us everywhere we need to go to find out.
We got 20 minutes, guys. I got some links for you.
You can have 4.
Thank you. I'll only take 2. So I just sent Paul some links to share with you guys. I'm not sure if that chat is everybody, but the first thing I want you guys to do is just follow the NVIDIA Embedded channel. I'm the humanoid that kind of helps manage that channel. So check out at NVIDIA Embedded on Twitter, Facebook, and our Instagram page, which is newly launched. You can also go to a really cool page on the NVIDIA website called Learn AI. I sent that link over as well. The Jetson Communities page, like I mentioned, it has some really great inspo, videos of projects and write-ups on really cool projects, especially from Song Hong's MIT lab. So check that out. There's good stuff in there. And if you want to get in touch with me, you can go to my LinkedIn page. I'm on there all the time. So send me questions, comments, or just connect. I added a link to my profile. And yeah, buy a Jetson Nano. That's the next thing you should do right when we hang up this call.
Yeah, I think I forgot that I'm also on LinkedIn. So if you can find me, my name is Chintan Shah.
And big shout out to Erik, by the way, for being a guinea pig and the experiment with Paul.
Yeah.
You guys did an excellent job.
Failing publicly.
Yeah. You're a brave man.
So-
And setting up also this thing, all the infrastructure and stuff, all the expertise. I mean, this is my first time being introduced to this kind of streaming LBS Ninja, and you guys got it down to very easy. So thank you.
I like fragrance-free Vaseline is called all us gentlemen out for having boring white walls. You having the beautiful base over there next
Flowers.
to
You know, I thought of
you. A nice dining
about
set it looks like behind you.
Yeah,
I
I'm
thought
ready for a
about putting
party.
something like a flag or something in the background.
Yeah, COVID has killed all my parties, so everything's there. Usually there's like dirty shot glasses and things everywhere, but we'll have a party soon once we get a vaccine. So
Jaime and I have jokingly noticed that we actually live in the same room. I think
it's like it's just
and we know it's actually the same exact door if you pay attention to it.
It's like a portal. I open the door.
Yeah,
I
if
don't
you
know if
open
I'm
the
gonna get
door-
into my house, so I'm going to go to.
and that side door he
houses.
has, I've also got that one too. I can't exactly get it in the frame,
Wow.
but we live in the same house. It looks like but we're in
So-
different states.
For Microsoft Build, a coworker and I, Brian Kettleson, we're streaming. We're collaborating, and people noticed that the wall looked kind of the same, but we were on 2 different cameras, and it tripped him out because I just reached over, and of course my hand comes. We were next to each other, just with 2 cameras.
Yeah, it's a nice trick, right?
So I'll go second to last here. So the big thing I want everyone to know is we created all this content in preparation for something that we've coined July OT. That is a pun I can claim that we made up back in February. We rolled with it. We were so happy that July rolled around. We wanted to fill a whole bunch of content up for that. And this presentation, the project that Erik and I worked on, and a number of other projects from a number of individuals at Microsoft and contributors from places like Hackster.io and Dev2 are building projects in that vein. And we are tracking at least all the ones that we're creating at Microsoft at julyot.com. And that will bring you to a tech community blog post that has links to all of the series that Erik and I have recorded, in addition to all of the sessions that will be coming up for the other projects that we have slated throughout the month. So I would definitely say, if you want to get started with IoT, this is the month to do it. and hopefully some form of content that we've created throughout these 30 days has inspired you in a way to pursue that as a topic or hobby of interest.
All right. Well, thanks everybody for tuning in. Anybody who's interested in me attempting to solve this OBS on Nano thing that I just committed myself to, I guess whisper me on Twitch and we'll figure out a day that works for everybody who is interested in that. And I'll try to stream based on your availability, folks who are interested in that. And we'll see how that goes. No promises because we're figuring it out live, but that's apparently what I volunteered myself to do lately is fail publicly. So
You have 2 days.
So follow Erik at his channel too. You do your own Twitch stream at erik.dev on Twitter. So yeah, make sure you follow him there.
Yeah, the individual projects Paul and I will work on and things like that over time will end up being on that channel. And then when we do big things like this and get NVIDIA coming on, we'll do that on the Microsoft Developer channel.
And I just want to let y'all know, one of the first questions asked, I didn't want to take it, was, are you guys going to do these weekly? That might be too much, but
quarterly.
If you all hit us up on social media and say you want more, and you have to spell it MOAR, like your angry mob, we might do it again. So just hit us up on our social channels. You know where to find us.
Awesome. Thanks, guys.
Thanks, everybody.
All right,
Awesome.
Have a
Thank
good
you.
one.
Great.
Okay.
Bye, Nano.